Hi everyone. So, have you ever wondered how your message, like on WhatsApp or maybe Instagram, stay private? All of that is possible thanks to something called cryptography. It's actually built on math, and not just any math, it's based on something called discrete mathematics. So first, we got something called number theory. You can think of number theory as the study of numbers, especially prime numbers like 2, 3, 5, 7. So in cryptography, prime numbers are like secret ingredients. Why? Well, because when you multiply two big primes together, it's really easy to do, but it's super hard to reverse it and find the original primes, right? So that hard to reverse part is what makes some encryption safe. Alright, so next is something called modular arithmetic. I hope I pronounced that right. It's actually like clock math. Let's say it's 10 o'clock now and you add 5 hours. What time is it? If your answer is 15, it's not 15 o'clock, it's 3. That's because clock wrap around after 12. In modular arithmetic, we do something similar, like numbers reset after reaching a certain value called the modulus. And this is help a lot to keep the numbers within a certain range, which is super useful in encryption because it makes sure things don't go out of bounds. You know how computers use zeros and ones, right? Well, Boolean algebra is the math of zeros and one. So it uses rules like 1 and 1 equal 1, 1 and 0 equals 0, 1 XOR 0 equal 1. So these logical rules help computer combine, flip, and lock information. So they are used a lot in symmetric encryption, where the same key is used to lock and unlock the message. And finally, to sum it up, cryptography isn't just about writing secret messages. It's about using math, the kind of math that works best in a digital world. Alright guys, now that you've seen how math powers cryptography, I'll let my friends Adi to take over and show you a real example on how RSA encryption actually works.
Okay, so thank you for the time, Ila. Right now I will have to explain RSA. So this algorithm needs two keys, public key and private key, to encrypt and decrypt our messages. The first is you need two prime number, ideally very large one. Okay, let's pick P and Q 7 and 11. Okay, we need to set the n, so n is equal to P times key, so that total has to be n equals 77. Now this number n will be used for our both private and public key. We need to calculate the Euler-Totian function, so it is like this. Plugging our number, we get this. This number is our secret key to generate our private key. Now let's choose a public exponent. We need to satisfy this requirement. E should be bigger than 1 and should be smaller than the Euler-Totian function we just calculate. Let's choose, 13, the D, like the alphabet, D exponent. Using this function, we can find it. And I'm just gonna show you a little magic editing trick. There you go, that's our D. Now we both have our public key, which is 77 and 13, and we have our private key, 77 and 37. Let's now start with an example. Let's encrypt high. So we're gonna convert H and I into the numbers. We got that 8, 9. We're gonna encrypt 8 using our public key. The result of H, which is encrypted with our public key, should be 50. And now we're gonna encrypt I, which is 9. So blah, 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 blah. We get 58. Okay, we got our encrypted message, which is 50 and 58. Encrypted messages, we need to use our private key. Okay, using this formula, which is Okay, calculating that, our decrypted number back 8. Let's do the same for 58. Okay, using our little magic editing trick, it goes back to 9, and we got our original message, HI, hi. Discrete math provide a good foundation of how the algorithm works. And for the last one is like enabling trust and providing a security. Okay, there is a one use cases of cryptography that I know, which is cryptocurrency, but I'm gonna explain it later in the next video. Bye.